All right. Oh, I should measure the length of this thing. Hang on. I'll time it first and then measure length. I'm getting old. All right, ready? I'm gonna pull back. I'm gonna let go. I'm gonna get a good rhythm. Ready, go. And 1, and 2, and 3, and 4, and 5, and 6, and 7, and 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and stop. All right, put some times in chat just to compare them to each other, though you only have to record one of these. So you record your own. Change that to 62.16 and 62.17 because you want them in seconds. Karen, can you come over here and help me?
Yes.
Come on, this way. Come on.
What?
Did you go upstairs? I need you to hold this end where the string is. See where the string ends up there, where the right where the string is. So I need you to hold it there, at that height. So I'm going to measure the length of this thing. Okay? Thanks. I'm getting too old for this. Hold on. Now I want to measure to the middle of this thing. In this case, since most of the mass is down here, I'm going to measure down to here. So I got 155 centimeters, okay? Okay, whoa. Hey, stop, okay. So I got 155 centimeters. All right, thanks. Stay if you want. Okay, so now we gotta close up a little more. Okay, so now I gotta make it shorter. So I'll just go up. So I'm not gonna worry about the string. I'm gonna go ahead and cut it. That's it. Make it shorter.
Hi.
Oh, wow, I made it too short, didn't I? Oops. All right, well, maybe not. All right, well, let's go for it. Okay. Well, darn. All right, it's up here now. See? Okay. Okay, so ready for 25? 25 swings of this thing. I'll pull back. Okay. Yeah, 155. Okay, ready for this one here? All right. Ready and go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Stop. Sorry. Hopefully you stopped at 25. Put the times in chat. Okay, 41:39. Okay, let me measure this one. This one is 68 centimeters. All right, you guys ready again? Ready, go. 1. Oh, wait, it didn't do it right. I'll start that over again. Are you ready? Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 1, 2, 3, 4. Stop. Okay, how'd we do? 20. Okay, good. Consistent at least. Could be completely wrong. This thing is 42 centimeters. That one's 42 centimeters, okay? All right, you ready? Let's again. Okay, let's just do this. 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Stop. This one actually started swinging from here, so I have to change the length here. All right, so the length of this one, I get 18 centimeters. So 18 centimeters was the last one. Now I need to make one more, but I need to make it a little bit longer. So I think this one's. We'll do things a little different because we have to improvise. I have to improvise this because kind of messed up. Normally I'd be ending with the shortest one, but I can't. So this one is. So this one's 136 centimeters. I don't want that one. I don't want that long. So let me go take a few centimeters off this thing. All right. Okay. So this is the one we're going to use for our last one here. And I'm going to actually do the test for this one too. I'll try to keep it here. This one is 104 centimeters. Okay, so this one, last one's 104 centimeters. And I'm actually going to do the two tests with it. All right, so I'm ready to count as I pull this thing back. Here we go. Problem is, it oscillates in this one direction. So, ready? Whoops. Sorry. Ready and go. And 1, and 2, and 3, and 4, and 5, and 6, and 7, and 8, and 9, and 10, 11, 12, and 13, and 14, and 15, and 16, and 17, and 18, and 19, and 20, 21, 22, 23, 24, and 25. All right? So what are the times on that one? All right. So 52.26. All right, so for the two tests down at the bottom that you guys are going to do, if you're doing them with me, we're going to do it yes, this goes between the first two. That one goes between the first two, yes. So sorry, I kind of did them out of order. That one goes between the first two. All right, so now we're going to do the large angle test. This one, we're only going to go for 10 swings of this thing. So are you ready for this? This was 103. Well, no, sorry, 104 centimeters, this last one. Okay, ready for the big angle? So we're only going to do 10 of these swings because it'll soon go back to the small angle. You ready? Hold on a second. I got to pause the meeting for a second. I'll be right back. All right, so we're going to do the large angle. So it's a large angle. It's going to be the same measurement as before, which is 104 centimeters. So I'm going to pull this back big. Can't do it too big, and I will let it go. But we're only going to do it for 10, and I'm going to do it immediately as I let go. All right? Okay, you ready? 1, 2, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop. All right, put some times in chat there. Oh, really? Wow. Okay. Yeah, okay. All right, let's see. Now I need to find something to add mass to it. Here. also work. Okay. I'm going to tape these things together somehow. All right, this is good enough because they're going to swing together. So I'll just kind of clamp it somehow. All right, it's good. All right, so now I'm going to swing this thing, and I'm going to do 25 again, but I'm going to do the small swings. Okay, so we're ready. So last one here. So I'm going to get a good. I'm going to get a good rhythm here, and start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 20, stop. All right, so a couple times in chat. Let's see what you got for that one. All right. Okay, looks good. So let's go ahead and analyze data. Somebody's going to have to tell me what the data is. Now I can turn on my fan. I got it so hot in here.
Here's the other fan.
No, I like that fan. Other fan's not hot enough. I'm burning up. Your mom keeps wanting me to turn up the heat. Now I am working on a video that I did in the laboratory that has better data. So hopefully it'll be better than this one. I gotta find my mouse. Hang on. But let's analyze this data, and see what we get. Let's see who's all here. All right. So I'm going to share my screen. I'm going to open up Excel. Hang on. All right. All right. So y'all can see Excel here. So first of all, let me just go ahead and kind of do this. So what were the links? And we're going to put these in centimeters just because, you know, that's what we recorded them as. So we'll put up centimeters here. So I'm going to kind of do this whole thing in Excel. So the length in centimeters is what for the things? I know it was 155 for the first one, right? And then we had the 104, which I said to put between those two. And what was after that? So somebody needs to voice chat me because I don't think I can see the chat.
68,
Oh, there it goes. 68,
42,
42,
18,
and 18. All right. And then the lowercase letter t's, which was for in seconds. And I'm going to put a little subscript on the little t to remind myself that we did that for, or can I do subscripts here? Maybe I can't. Let me see. No, I can't do subscripts. Well, fine. All right, so I'll make a smaller font. So I want to go 9 and put a little 25 so that I just remind myself that these are for 25 swings, okay? And so what were the times there? The first one was 60 point something, right? Or 62 point something?
16,
62 point what?
16,
Okay. Okay, what's the next one?
52, 43.
Oh, no. So for the 104. So
Yeah.
this was the last time. So what was the time for the very last one we did?
52.43.
Okay. You guys use your own times, which might be slightly different here. Okay. So what's the
41,
next time? Go ahead.
39,
39.
41.
Point
No,
what?
it's,
10.
41, 39.
Okay, 4139. Okay. There we go. What's next?
2903.
Uh-oh. Here, hold on. Let me get my headphones. Okay. That might be better. Can you guys talk? Okay. So what did you say for this one right here?
2903.
Okay. Much better, much better. Because even though you guys can't hear the music, I can. It's my neighbor. Hey, is that me? Did I do that? Okay, that's interesting. I didn't mean to do that. All right. So what's the last one here?
2032.
All right. All right. So now what we're going to do is we're going to take the capital P, the period. The period. And that's going to be in seconds. Okay. And this is going to be our capital T. So I'll go ahead and put capital T. Okay. So we're going to, now I'm going to do this on Excel. All I need to do is say that if I want to do something on Excel, I say equals, and I click this number, and I want to divide that by 25. And there's my period. So I'm going to take that, I'm going to copy, I'm going to go down like this, and paste. So what that does is in Excel, that pastes the formula. So if you have this number here, and I'm doing the same thing to every number to go over here, then I can copy the formula from the one place, and then I go down the column and then paste it. Now these numbers here should all have 4 significant digits. You guys can still hear me, right?
Yeah.
Okay, okay. All right. So I'm gonna take this little, see where my mouse is right here? I'm gonna pew! All right, there they are. Except for the very last one, which is fine. Now the thing is that I'm gonna do one more preparation here because when we do our graph, we're gonna want to do t squared. We're gonna want to do t squared. So I'm gonna take that. I'm gonna say this is equal to, and I'm just gonna do it the easy way because I forgot how to do like squares. So I'm just gonna say this times itself. There it is. Copy this. Paste down the column. There we go. So that's my t squares. Now that should also have 4. So let's go back to 4. There we go. Okay, so that's our first thing here. So now what we want to do is we want to take t squared. Hang on, let me see what it says. You go get your instructions to make sure. Oh, wait, I need to share the screen so you can see what I'm going to be looking at. Oh, sorry, you need to share screen. This one right here. Okay. So I want this one right here. Okay, so here it is. Okay, so we're here. So I want to do a plot of L versus T square. Okay, so the length versus T square. So I'm going to go back to Excel. And I'm going to go down here in these other columns. And I'm just going to do the length and the time squared. So length. I'll go ahead and keep these in centimeters. Copy. Paste these here. And then the T squares. Now for this, when I do copy and paste, I want to do it slightly differently because up here there's formulas, but I don't want formulas. I want to copy. And instead of when I go to paste, I want to just paste the second one, the values. So it's a little trick. You can use Excel. If not, you just do it by hand. Okay. It's perfectly fine to do things by hand. All right, now we're going to plot this. Okay. So do you have your two columns ready to plot? Whoops, I messed up. All right, I apologize. Okay. 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 I need to have this in the first column, the t square in the first column, and then the length in the second column. Because we want t squared on the x-axis and length on the y-axis. Microsoft is tricky that way. All right, let me go into look in the chat here. See if this. All right, so so when you get this far, let me know.
Okay.
Not you.
I'm good.
A couple more people are okay.
Yes.
Okay. All right. All right. So now I'm going to do this plot. So I'm going to highlight these four things right here. These right here. And just like we did last time, we go to insert. We're going to want an XY scatter. Scatter. And I guess I need to zoom out. There it is. Okay, well, at least it looks kind of like a straight line, right? It's a little bit wobbly there, but it looks kind of like a straight line. Actually, it kind of looks like there's a straight line here and then a kind of another straight line here for the longer ones. And that's because of the way I set it up. So if you're actually using your own pendulum, you might have a better setup than I do. It turns out that that banister I was hanging it off of is not a very good pendulum support because it favors pendulums in one direction over the other. So we'll see. Anyway, you all ready to do the next step here?
Yeah.
The next step here is we're going to add the trend line. Once again, I'm going to go ahead and click it, but I want more options. Give me more options. I want it to be linear, but I want to display the equation on the chart. So I'm going to display it. There it is. Okay, so Let me custom zoom this. Still made the chart too big. There we go. There you go. See the whole thing at once. And just because we want to do this, we want, hey, give me that back. That's not what I wanted. I want to edit inside here. Okay. So I want length versus period squared. Okay. I wish I could make this bigger somehow. Can I make it bigger? I can't make it bigger, can I? I can move it, but I can't make it bigger. Okay, fine. All right, now let's go back to our instructions. New share. Let's go down here. Now, is your data L versus T squared consistent with the relationship between the two variables, even if specific values of T aren't? Oh wait, sorry, that's the report questions, sorry. Okay, the slope of your graph should be G over 4 pi squared. Calculate the experimental value for G by multiplying your slope by 4 pi squared, okay? So that's what we're gonna do. So we wanna take the slope that I got, you take the slope that you got, whatever the slope is, and multiply by 4 pi squared. So I'm actually gonna do this here in Excel. So this is equal to the slope. So I'm going to take 23.81 times 4 times. Now to do pi in this thing, you got to do this. You do pi times the pi function again. And Microsoft Excel has a pi function. So that's 4 pi squared times the slope. And let's see what I get. I got 900. Wow. Better than I thought. So let me, there you go. So this is experimental G. G experimental. Okay, 940. Okay, everybody get something close to this experimentally? 940 when you did that with your slopes? Okay, 918, that's good. So everybody's getting something good with our slopes. Okay, so now it says calculate the percent error G compared to the accepted value of, hang on, I got to do new share here. New share here. Share this. Okay, let me use Zoom here. Oh, okay, hang on. I got an idea. Hang on. Let me go back. Instead of doing this. I'm going to download it. And I'm going to open it up in PDF. Can you still see the PDF file here I have? The PDF sharing?
Yes.
Okay, good. All right. Okay, so the value here is 9.797, which might make you panic for a little bit because we've got 900 and something. But remember, this is in meters per second. So when we compare to centimeters per second, we have to multiply this number by 100. So it's 979.7. That's the one we're going to compare it to. Okay? So that's our accepted value. So then I'll do the new share here. Right over here. So in fact, I'll just go ahead and put G accepted just for reference. So it's 979.7. Just enter that number. And now we're going to calculate the percent error. Okay, percent error. I'm going to calculate it on here. So your guys are seeing Excel, right? Did I do that correctly? You're seeing my Excel? Okay, good, good, good. All right, so I'm going to say this is equal to absolute value equal to abs, something I don't have. I don't have abs of this experimental minus accepted divided by accepted value. And then all that, so I do have to put parentheses here, all of this times 100. 4% error, not bad. I can reduce this. Yeah, 4.05%. That's pretty good. Yes. I'll say that's pretty good for some makeshift thing I stuck up on a banister in my house. All right. So now we want to look at as a group, you can answer the questions. So I'm going to answer this questions right here. So it says, what should the value of the intercept of the graph of L versus T squared be? Is your value consistent with this? So let me go back up to this theoretical equation we have right here. This T equals 2 pi times the square root of L over G. And now I'm going to do this. Go to speaker view so you can see me. All right, and let me grab a. All right. Kieran, you can turn off the fan if you want to. All right, so the way this equation works, and I know this isn't the greatest thing in the world to use, but I use it anyway. So we got T equals 2 pi times the square root of L over G. And then to get that theoretical equation, we have to solve this for L. So I got to square both sides. T squared equals 4 times pi squared L over G. And now I'm going to reverse the sides and divide by 4 pi squared and multiply by G. So what I get is I get L equals G over 4 pi squared times T squared. So I get this. Okay, now we're going to compare it to the equation for a straight line, where this is the y, and this T squared is your x. So that's your y and your x. So we remember that the equation for a straight line is y equals slope times x plus intercept. So So we already saw that the slope corresponds to the g over 4 pi square. So what does the intercept correspond to here? What's added to this term here in the equation? Any takers? All right, well, think about that. Let me give you a hint. There's nothing, right? There's nothing added. It's all here. There's nothing over here. So what should the intercept be? Should be 0. Okay, so the intercept should be 0. Okay, it's not going to be quite 0 because our data is not perfect. But if we look at it compared to the slope, I go over here and I compare the intercept to the slope, I notice that it's very reasonable with that large of a slope to have a little intercept like that. So if I share this back on Excel, I've got an intercept of 4.3. It's close, okay? If I got an intercept on the order of my slope or something large, like 100 or something on the order, the other way to think of the intercept is kind of the length with 0 period. And the length with 0 period is 4. Kieran, kid. And so 4 is small compared to all the numbers we use for our length. So there you go. So it works. Okay? So you compare it to the other lengths. So it might kind of affect that 18 a little bit, but it's not going to affect the other ones very much at all. Okay? All right, let's look at the next question. Next question says, let's go back to the next question. So question 2. Is your data of L versus T squared consistent with the relationship between the two variables? In other words, is the graph a straight line? So you just kind of describe your graph and say whether it looked like a straight line or not. Now for number 3, what we want to do is we want to look at that last pendulum that we did with the large angle. So I'm going to go back to Excel for this because it's a little tricky for our class. Because our class didn't use we used the 104 length pendulum, okay? So let me go back over here. So with a large angle, the experimental G, you take the slope times 4 pi squared, and this is given. So the time for the large, I'm sorry, the little t for the large. What was our little t for the large angle? I'll put LA for large angle. So what was our little t for that? Where we just did the 10 swings, I think it was like 20 point something, but I'm not sure.
1.08.
21.08. Okay, we'll use this one. All right. So now we want to find the period for this large angle one. And so we want to take this number and divide it by 10 because we only did 10 swings. So it's 2.108. Okay. So now these are both for 104 centimeters. So let's go back up and take this period right here, 2.097. Okay, so this is period for the small angle. Okay. And now we want to compare these two to find out how much percentage increase or decrease it has. So to do that, we kind of do it like a percent error. So I'll say percent increase. And that's going to be equal to, I'll put the 100 first, times the absolute value of, actually, that's fine, of this, the large angle, minus our regular one, divided by the regular one. So it's not very much of an increase. What I got was, I get like 0.52% increase. So in other words, the large angle didn't make that much of a difference, or didn't make a difference really, which is theoretical because it shouldn't make a difference. And then the last question, which is a notebook question, but we can go ahead and answer it here, is we're comparing the tea putty with your with the added mass with the not added mass. Okay, so go back over here to Excel. So little t putty. So what was the little t? I'll put putty even though we didn't add putty. I added keys and something else. Yes, I will share this on to your guys' website. As soon as Zoom's done, I'll put it on YouTube and they'll share it. Yes. Okay. What was our T putty? The time for the keys and the thing? What was the time for that? Okay, 51.73. And so now I need to take that number and I need to divide it by 25. So capital T putty equal to this divided by 25 gives us that. And then T no putty is our 2.097. And so we want to compare these two. And the idea is, does the mass make any difference? In other words, are we justified in saying the mass doesn't matter when comparing these two together? And that's for your lab, well, notebooks, but lab journals, wherever you're putting them online or whatever. Okay. R squared. Did I ask you for R squared somewhere? Oh, hang on. I did ask you for R squared, didn't I? All right. Let's go back up here. Let me do this trend line again. This time I'm going to just do trend line. Give me those more options. Give me the more options. Sorry, more options. More options. The trend line, more options. This one, I want to display the equation on chart and display the R squared value. So there's the R squared value. Okay, so I just, it's in my line things. I just click display R squared value on chart. Okay. All right, I guess that's it. So yeah, so I'm going to close out here and then I'm going to render this thing up and put it on YouTube. All right, so thank you all for coming. You came. So it's good to see you all, or at least see you all virtually.
Thank you.
You're welcome.
Have a good day.
You too. Try to be safe. Don't worry. We'll be back next week with the Wave Lab. Bye.
Oh, I had one last question. Sorry.
Go ahead. No problem.
It was about last week's lab as well. So the last question on the lab, it says, is the correction validated by the spring?
Oh,
it would be validated, right?
If your percent error with the correction is less, that validates the correction.
Okay.
Yep.
Okay, great. Thank you.
You're welcome. All right. See you, Jeanette. Bye, Josh. There he goes. Bye-bye. Stop recording.